I hope you are well again. I'm sorry that, So we are going to look at grade 10 linear number patterns, okay? Linear number patterns in grade 10. And specifically, we look at the general term of our linear number pattern. Tn is equal to b. Now, if we look at Tn is equal to Bn plus C, this is the general term of any linear number pattern where B is the constant difference. And if we look at B, the constant difference, the way in which we calculate the constant difference is we say term 2 of the sequence minus term 1 of the sequence. And then if we take term 3 and subtract term 2 of the sequence, we should get the very same what? Value for our constant difference, because a linear number pattern is a pattern whereby the first difference is what? Is constant. So if we write Tn is equal to Bn plus C, and then in the place of n we substitute natural numbers 1 in the place of n, that means term 1 in terms of B and C is going to be equal to B times 1, which is B, plus C. So term 1 is equal to B plus C, grade 10s. Then term 2, if we substitute 2 in the place of n, that means we get 2 times B, which is 2B plus C. That is term 2 in terms of B and C. Term 3, which means in the place of n, we substitute 3. B times 3, that gives us 3B plus C. So term 3 is 3B plus C. If we substitute 4 in the place of n, that means B times 4 gives us 4B plus what? Plus the C. So we have 4B plus C. So that means in terms of B and C, term 1 is B plus C, term 2 is 2B plus C, term 3 is 3B plus C, term 4 is 4B plus C. Term 5 would obviously be 5B plus C. So then, if we then calculate what is the first difference, that means if we take 2B plus C and subtract B plus C from it, what's 2B minus B? That will give us B. And then what is C minus plus C? That will give us 0. So that means we only have B, and B stands for the what? The constant difference. Let's move on to 3B plus C. 3B plus C minus 2B plus C. What's 3B minus 2B? That's also going to be B. Then what's C minus plus C? That will give us 0. So we are left with B again. What about 4B plus C minus 3B plus C? What's 4B minus 3B? That also gives us a B. And then what's C minus C? C plus minus C gives us 0. So that means we have 0. So our first difference here, guys, is B, B, B. In other words, our first difference is constant. In other words, our first difference is the same for a what? For a linear number pattern. So that means, generally speaking, with our general term of a linear number pattern being Tn is equal to Bn plus C, where our constant difference B is B, B is equal to 2t minus T2 minus T1 and T3 minus T2, we can clearly see that even from a concept standpoint, our first difference for any linear number pattern is really constant. Okay, so now we are going to look at some questions around these linear number patterns, and hopefully we will gain and learn a lot from them. So let's look at this first question. Consider the pattern -1, 2, 5, 8, ... all the way to 116. And the question says, write down term 4 and term 5 of the number pattern. For how many marks? For 2 marks. Consider the pattern -1, 2, 5, and 8. First term, second term, third term, fourth term. Now they are saying write down T4 and T5 of the number pattern. Okay, so let's go back to this original sequence. Let's first write down the numbers: -1, 2, 5, 8. Now we want term 4 and term 5. Term 4 already we have is actually equal to 8. What we need now is term 5. Okay, so what we are going to do is we are going to check first what is the difference. 2 minus -1, that gives us 3. 5 minus 2, that gives us 3. 8 minus 5, that also gives us 3. So this is a linear pattern. We can see that because our constant difference is 3. Then what we should observe is that when we take -1 and we add this 3, that gives us the 2. So -1 plus the 3 gives us 2. 2 plus the 3 gives us 5. 5 plus the 3 gives us 8. So then that means 8, we can expect that because our difference is constant and it's 3, 8 plus the 3 should give us the 5th term. What's 8 plus 3? It is 11. So that means term 5 is actually equal to 11. So when they ask us to write down the terms, term 4 and term 5 of a number pattern that we have been given, then we can use the concept of constant difference and then adding the constant difference to the previous term to be able to locate the value of the next term. So this is something that you need to note when you are asked a question of that nature. Let's move on to the next question. Write down the general formula for the nth term. Write down the general formula for the nth term. Write down the general formula for the nth term. Write down the general formula for the nth term. Okay, so in order to find the general formula for the nth term, what we need to note is that Tn is equal to Bn plus C. That's the first thing we need to note. Okay, then what is B? Remember, B means our constant difference. We can see that the constant difference here is what? Is 3. So what we are going to do is we are going to say Tn is equal to 3n plus C. And what do we need now? We need the value of C. Now there are two ways to get the value of C. And one of the good ways to find the value of C is to note the very following. Okay, you can go and select a term in the sequence, any term, doesn't matter which one. So let's say we go and select the term, this one, which is 5. What position does this term occupy? So we know this is the first term, second term, this is the third term. So that means if we choose the number 5, then we need to also know the position of the number 5. Okay. So the number 5, the value of the term, which is 5. So if I choose 5, in the place of Tn, I'm going to write the number 5. Then in the place of n, I write down the position of the term. The position of this term, 1, 2, 3. It's occupying position 3. So that means in the place of n, I'm going to write down 3. Okay. So the value of term is 5. The position, or n, is 3. So then you substitute the value of the term in the place of Tn. Okay, and then you substitute the position 3 in the place of n. So there it is. 5 is equal to 3. In the place of n, we write 3 plus c. Then now we solve for c. 5. What's 3 times 3? 9. Okay. Then what do? We transpose the 9 over to the other side. 5, take the 9 over, minus 9 is equal to c. Therefore, c is equal to, what's 5 minus 9? It is negative 4. Therefore, if we write down the general term of the formula, it's actually 3n minus 4. This is how we get the general term, okay, by calculating the constant difference, which we found here. The constant difference is 3. So in the place of b, we write 3, okay? And then to find or solve the value of c, you can take any term in this sequence, any. If you take 5, then it means you substitute its position in the place of n, which is 3. Had we taken 2, okay, we would write 2 there, okay? And I just want to show you that it will work just as well. Let's say we had decided to take 2, okay, 2, and let's say we took their position as well, because 2 occupies which position in the sequence? It occupies the second position. So that means we would say 3 times 2 plus c. Okay, then we solve for what? We solve for c. 2 is equal to 3 times 2 is 6. We transpose the 6. We get negative 4. Therefore, Tn is equal to 3n minus 4. So you see, we still get the same Tn. Let us say we had decided to substitute another term, not specifically the 2. Let's say we had decided to substitute 8. We substitute the value of this term. What position does 8 occupy? First term, second term, third term, fourth term. So if we substitute 8, the value of the term is 8. What position does it occupy? It occupies the fourth position. So if we say we choose the value 8, then the position it occupies is the fourth position. So in the place of n, I substitute 4. In the place of Tn, I substitute 8. In the place of Tn, I substitute the value of the term. In the place of n, I substitute the position of the value of the term, which is 4. Then I solve for who? For c. 3 times 4 is 12. Then I say 8 minus, I take the 12 over. Therefore, c is still equal to what? To negative 4. What is the general term? Tn is equal to 3n minus 4. Okay. So all in all, guys, I think this is the most accurate way to actually calculate the value of c. Okay. So let's move on to the next question. Determine the value of the 33rd term of the sequence. Determine the value of the 33rd term of the sequence. So by 33rd term, what is this speaking to? If we say 33rd term, hopefully we understand that this is speaking to the position of the term. And obviously that means we have the value of n. And what do we want? We want the value of the 33rd term. So what we are given by 33rd, we are given the position. In other words, we can slot in the place of n 33 in this general term, so that we can calculate the what? The value of the term, of the 33rd term. So let's go. T33 is equal to 3. In the place of n, because we said T33, we substitute 33 minus 4. Then we calculate 3 times 33 . So what is the value of the term? Term 33 is 95. Okay, there it is. So determine the value of the 33rd term of the sequence. It is 95. T33 is 95. That is the value of the 33rd term. Next question. How many terms are there in the sequence? How many terms are there in the sequence? If the last term is equal to 116, repeat, how many terms are there in the sequence if the last term is equal to what? To 116. So remember here that we want to know how many terms there are in the sequence as a whole. And we are told that the last term in the sequence is 116. So if we know that the last term in the sequence is 116, it means we can take Tn and we can say Tn is equal to 116. Then we take this Tn, which the formula of the Tn we know is 3n minus 4. We equate it to 116. Then that then helps us to solve for what? For n. Why n? Because n is going to give us the position of the last term. The minute we know the position of the last term, that will give us an idea as to how many terms in total there are in the sequence. So let's solve for n. 3n is equal to, we take the negative 4, we transpose it. So 116 negative 4 on the other side becomes plus 4. That means 3n is equal to 120. Then what do we do when we are here, guys? In order to solve for n, we simply divide both sides by the coefficient of n, which is 3. Then we get what? N is equal to 40. So that means 116 is occupying the 40th position. If 116 is occupying the 40th position, that means in total, how many terms are there? If this 116 is the last term, it means in total there are 40 terms. So how many terms are there in the sequence if the last term is equal to 116? I took Tn and I equated it to 116, wrote down the expression of Tn, which is 3n minus 4, equated it to 116, solved for n, took the negative 4 over, plus 4, 116 plus 4 gives me 120, I have 3n is equal to 1820, divide both sides by the coefficient of n, which is 3, n is equal to 40, it means therefore there are 40 terms in the sequence. I conclude as such because the question was asking how many terms are there in the sequence if the last term is equal to 116. So therefore, that's how I conclude. So hopefully grade 10s, that makes sense to you. That makes sense. And we are good. Okay. Let's look at the next question. A linear number pattern with a constant difference can be expressed by terms. Okay, let's look at this. Given 2x plus 2 and 3x plus 2 and 5x plus 6. If x is equal to 0, calculate the numerical value of the fourth term and hence determine the nth term of the sequence. Let's look at this again. Given 2x plus 2, 3x plus 4, 5x plus 6. If x is equal to 0, calculate the what? The numerical value of the fourth term and hence determine the nth term of the sequence. So guys, what are they asking here? We are given terms in terms of x. This is term 1, there's a semicolon, which means this term is separated from this one. Semicolon means and, so it's 2x plus 2 and 3x plus 4 and 5x plus 6. There are 1, 2, 3 terms in the sequence. Okay, and what they are saying is if x is equal to 0, calculate the numerical value of the fourth term. If what? If x is equal to 0. So let's go and first write down the sequence in terms of x. 2x plus 2 and 3x plus 4 and 5x plus 6. Let us substitute 0 in the place of x so that we can get the actual values of each term. So if we substitute in the place of x 0, as it says, 2 times 0 plus 2. That will give us what? 2. Next term, 3x plus 4. 3 into 0 plus 4 gives us a second term, which is 4. 5x plus 6. In the place of x, we substitute 0. That gives us a third term of 6. Now, I'm sure you guys can see that there is a constant difference, okay, which we can obviously see b is equal to t2 minus t1. That means 4 minus 2. 4 minus 2 is equal to 2. That is our constant difference. So we have a constant difference here of 2. Our fourth term is going to be what, guys? It's going to be 8. That is our fourth term. So we have a first term of 2. That's the numerical value. Because remember, it says if x is equal to 0, calculate the numerical value. Numerical means the number value. We don't want the term in terms of x. We want the numerical value of the fourth term. Okay, so the numerical value of the fourth term is 8. How did I find it? Like I said, I first substituted my x value, which is 0. If x is equal to 0, it means in the place of x, I substitute 0. 2 times 0 gives me 0 plus 2, that's 2. 3 times 0 is 0 plus 4, that's 4. 5 times 0 plus 6, that's 6. Then I write down my terms. 2, 4, 6. Obviously, my fourth term is 8 because I'm counting in multiples of 2 here. Okay, my constant difference as I calculated it, term 2 minus term 1 should be the same thing as term 3 minus term 2. What's 4 minus 2? It's 2. 6 minus 4 is 2. So that means 6 plus what gives me? 6 plus 2 gives me what? 8. So my fourth term is 8. Okay, because the first question was calculate the numerical value of the fourth term. So T4, guys, is 8. I have to write that down. Then next question says, hence determine the nth term of the sequence. Tn is equal to bn plus c. In the place of b, I write the constant difference. What is the constant difference? It is 2n plus the c. Then what can I do? I can take any value of the term, 2, 4, 6, or 8, and its position. So let's just say I take 6. What is the position of 6? It occupies the third term. So 6 occupies the third position. So I'm going to write 6 is equal to 2 times, in the place of n, I write the position plus what? Plus c. Then that 6 is equal to 6 plus c. I take the 6, I transpose it. 6 minus 6 is equal to c. Therefore, c is equal to 0. So what is Tn, guys? Tn is equal to 2n. 0 obviously is there. I don't have to really write it down. Tn is equal to 2n. That's about it. Okay? So the hence part, when they say hence, it means use what you have done previously to then go on and calculate the nth term. So remember, I had found the fourth term, which is 8, using my concept of constant difference to locate the fourth term. Now, since I know the constant difference, which is b, which is 2, I say Tn is equal to bn plus c, 2n plus c. Then in order to solve for c, I simply have to go and choose a term and its position, substitute the term, which in this case I chose the term 6, with its position n, which is 3. Then I solve for c. C is equal to 0. Therefore, when I conclude, what is Tn? Tn is equal to 2n. Remember, c is 0, so therefore that's 0. I don't really actually have to write it down because 0 is nothing. So therefore, Tn is equal to 2n. That is the general term of the sequence. Next question. Calculate the value of the 18th term for 2 marks. Okay, so when I have the general term, what's nice is that I can actually utilize the general term to calculate the 18th term. This 18th stands for position, and position means n. So that means this is my n. It is 18. So I'm going to say Tn is equal to 2n. T in the place of n, I substitute 18. Means 2 times 18 in brackets. Guys, what's 2 times 18? Let's see if in the comment section people are with me here. What's 2 times 18? Let's see if people know their maths here. What's 2 times 18, guys? Two times 18? Thank you. So that means that is the value of the 18th term. It is 36. Okay, let's move on. Next question. Which term in the sequence will be equal to 108? Which term in the sequence will be equal to 108? So which term in the sequence will be equal to 108? How do we calculate this? Remember, we are being asked which term. So what do they want us to find? They want us to find the value of n. They want us to find the position of this term, which is 108. So what we do is we say Tn is equal to 108. Okay, we must not confuse the question. Okay, we're not being asked what is the 108th term like this here. We are being asked which term in the sequence will be equal to this value. So we take Tn, we equate it to 108. Then we say Tn is 2n, so 2n is equal to 108. Then we solve for n. Divide by the coefficient of n, which is 2 both sides. What's 108 divided by 2? Let's see if people are here. What's 108 divided by 2, guys? What's the value of n there? N is equal to? What's 108 divided by 2, guys? My beloved grade 10s, what's 108? 108 divided by 2. Thank you. It is 54, grade 10s. It is 54. Okay, next question. Determine the largest value of n for which Tn will be less than 166. Repeat, determine the largest value of n. The largest value of n for which Tn will be less than 166. So what we do here is we say Tn less than 166. We take as it is 2n less than 166. Okay, then we solve the inequality. So we divide both sides by 2. We get n is equal to what? 83. Okay, so here's the thing. When n is less than 83, that's when we have a value of 160, a value that is less than 166. But if we are saying n is less than 83, what actual natural number is less than 83? Guys, what natural number is less than 83? Because we need the largest value of n for which Tn will be less than the value of this term. So if we are saying n is less than 83, what can n actually be equal to? What can n be equal to? What is the next natural number that is less than 83, guys? Because that natural number will give me a value of the term that is less than 166. So what is the next natural number that is less than 83? Because this question, you don't end it here. We need the largest value of n for which Tn will be less than 166. So if we are saying when we solve n is less than 83, my question is, what is the next natural number that is less than 83? What can n be equal to? What is the largest value that n can be equal to? Okay, people are sleeping here in this live. Ay, ay, ay. So n is 82, guys. Okay, because the immediate natural number that is less than 83 is 82, and it is the largest natural number that can actually give me a value of the term that is less than 166. So if you end here, you have not completed the question. N is equal to 82. Okay, that is basically our answer. Okay, all right, I think we're done with that one. Let's come here. The following values are the multiples of 5 from the number pattern 5, 10, 15, 20. The question is, determine the 16th even number of this pattern. The following values are the multiples of 5 from the number pattern 5, 10, 15, 20. Determine the 16th even number of this pattern. Okay. So hopefully we are together here. Okay. So if you think about it here, let's look at this, just this pattern as it is. Is 5 an odd number or an even number? 5. Is 5 an odd number or an even number? Do we know both what an odd number and what an even number is? Is 5 odd or even? Okay. So 5 is odd. What about 10? Is it odd or even? Even. What about 15? Is it odd or even? 15. Is this an odd number or an even number? This is odd. What about 20? Is it an odd number or an even number? Okay, the next number after this, since this isn't multiples of 5, will the next number be odd or even? That's the question. First and foremost, what is the next number? And then secondly, is it odd or even? Yes, it's 25 and it's odd. Very true. The next number after that, odd or even? And what is it? What is the next number? 30. Very good. And it's even. Now listen. Thank you very much. Thank you very much. Now they are saying here, determine the 16th even number of this pattern. So what do you observe? This is very important that when you look at this pattern, first and foremost, what do we observe in this pattern? So every odd positioned number is actually odd. Every even positioned number is even. First term, odd. Second term, even. Third term, odd. Fourth term, even. Fifth term, odd. Sixth term, even. You see? So basically every even position has an even number. Every odd position has an odd number. What do they ask us here? Determine the 16th even number of this pattern. So my question to you first, what is the first position of the even number? Okay, determine the, if I was to say to you, determine the first position of the even number. What is the first even number here? It is 10. What is the second even number here? It is 20. What is the third even number here? It's 30. You see that? So basically we have first, second, third. So now they're asking determine the 16th even number of this pattern. So, I mean, in your head already, if this is the first, this is the second, this is the third, then what is going to be the 16th even number of this pattern? The 16th even number. Okay, the 16th even number. Exactly, Wango. Yes, yes, very good, very good, very good. I'm very happy, very proud. Okay, I think you get it, you get it very well. You see? Yeah. I mean, so one would have to actually write these terms separately. 10, 20, 30. Then what do? You know most, this is T1. Okay, so these are your even numbers. This is T2. This is T3. Your constant difference is 10. If we were to calculate Tn of this particular sequence, it would be Tn is equal to 10n, because that is the constant difference, the coefficient of b, coefficient of n, which is b, is the constant difference. Okay, and then if we want to calculate the value of c, okay, remember, if we substitute this term 20, then we substitute its position, which is 2. That will give us 20. And then, of course, that's 20 minus 20, which is c, and c is equal to 0. So that means Tn is equal to 10n. If we want the 16th even number, then it means we say 10 times 16, which gives us 160. This is the 16th even number of this pattern, 160. So that's by calculation. The way we did it was by inspection, right? We inspected, we looked at the pattern, and then we concluded that, okay, 10, 20, 30, first term, second term, third term. Then we said, what is the 16th even number of this pattern? Then basically that would be 160, you see? But that was by inspection. By calculation, we are able to identify the terms, and then from that, calculate the constant difference, and then we are able to get Tn, which is 10n, and then from there substitute T16 so that we are able to actually get 160. Okay. Right. Yeah, so number patterns is being cooked. We are cooking number patterns here for grade 10. Hey, yeah, guys, this is grade 10. All right. Of course, if you are a learner in another grade that is above, you would also benefit. No problem. If you are in grade 9, that will also be benefit. But this is grade 10, term 4, as per their syllabus. Number patterns is there. Okay. We're doing that today. Okay, here's another pattern. X plus 3, 3x plus 2, 6x minus 1. Determine the numerical values of x and the numerical value of the third term. Okay, so we are given this pattern and we are told this is a linear number pattern. So the three terms of a linear number pattern are x plus 3, 3x plus 2, 6x minus 1. Then we are asked to determine the numerical values of x, okay, and the numerical value of the third term. So we need to first solve for x and then get the numerical value of the third term. Okay, so what do we do if we are told this is a linear number pattern? So first and foremost, let's write down the terms. Then let's use our concept of constant difference. Since we know we are told it's a linear number pattern, we know that the constant the first difference is going to be constant. So we are going to say 3x plus 2, which is t2, minus t what? t1, which is x plus 3. So we put it in brackets there. Okay. We are going to distribute the negative sign and then get the expression of the first difference. 3x plus 2 minus x minus 3. That means 3x minus x plus 2 minus 3. We get 2x minus 1. This is the first difference. Then we go here, we check 6x minus 1, term 3 minus term 2, minus 3x plus 2. Okay, we put this in brackets because there's a minus sign. Then we distribute the negative sign. We get 6x minus 1 minus 3x minus 2, because the negative times the positive is a negative, and negative times the positive is a negative. Then we group the like terms. 6x minus 3x minus 1 minus 2, that gives you 3x minus 3. Now, remember, what did we say? We said that the first difference of a linear number pattern is what? Is constant. So this 2x minus 1, we are going to say it's equal to 3x minus 3. Then we are going to solve for x. So I hope you understand what we've done here. We in essence said t2 minus t1. We got the expression for t2 minus t1. 3x plus 2 minus this x plus 3. Why do we put the x plus 3 in brackets? Because the negative sign will affect both terms. That's why we put it in brackets. It's a binomial, but as a monomial term, we put it in brackets. We take the negative sign, we distribute it, we get negative x minus 3. Then we add the like terms. 3x minus x gives us 2x, plus 2 minus 3 gives us negative 1. Then we come to this side. 6x minus 1 minus 3x plus 2. We do the same thing. T3 minus T2. So T2 minus T1, in other words, we are saying that T2 minus T1 is equal to T3 minus T2. For what? For a linear number pattern. Why are we saying that? It's because the first difference is what? Is constant. So the expression I get, which is 2x minus 1 from T2 minus T1, I must then say it's equal to what? To 3x minus 3. Then let's solve for x. Take the 3x. Take the negative 1. Okay, do you see what I did there? Take the 3x, transpose it, becomes negative 3x. Take the negative 1, transpose it, becomes positive 1. Negative 3 plus 1 is negative 2. 2x minus 3x is negative x. Then I get an x, divide both sides by a negative 1. Okay, when I divide negative x by negative 1, becomes positive x. When I do the same thing, divide the negative 2 by negative 1, becomes positive 2. So x is equal to positive 2. That is my value of x, guys. I've just found my value of x. X is equal to 2. And remember, what did they say? Determine the numerical value of x and the numerical value of the third term. Where's the third term? Here is the third term. T3 is equal to 6. Now, in the place of x, I can substitute 2 minus the what? Minus the 1. That's 12 minus 1, which is 11. So term 3 is 11. See? Okay. So this is so important. This thing of your linear number pattern in grade 10, you're sometimes given your terms in terms of x. When we say in terms of x, guys, we mean that the first term has an x term in it. You see, x plus 3, this is term 1. Term 2 in terms of x. You see, there's an x term, 3x plus 2. Term 3 is 6x minus 1. And they are asking you now to determine the numerical values of x and the numerical value of the third term. So in order to get the numerical value of x, what do? I use the concept of the first difference is constant for a linear number pattern. So I take term 2, subtract term 1. I get the expression 2x minus 1. I take term 3 minus term 2. I get the expression. Then I equate these two. You see, I equate them. I solve for x. After getting x, I can then calculate the actual numerical value of the third term by substituting x is equal to 2 in the place of x, so that I can then get the what? The third term, which is what? 11. 6 times 2, what mass? 12 minus 1 is 11. So term 3 is 11. Okay. Right, I hope this question was very meaty and good. Are we good? Can I continue? Can I continue? Next. Okay, let's go on. 3.1. Given 5, 8, 11, B, 17. Write down the value of B. So you tell me, guys. 5, 8, 11, B, 17. Write down the value of B. So B is equal to? It's always nice to establish first, because you can see this is linear. 8 minus 5, 11 minus 8. So 5 plus what? 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 gives us what for B? B is equal to what? Okay, very good. 14. You see? Because 11 plus 3 is 14. So yes, B is 14, definitely, no doubt. All right? Yeah. And then that 14 plus the 3 gives you 17. So it makes sense that B is 14. In two ways, we see that B is 14, because when we add to 11, 3, we get 14. When we subtract 3 from 17, we get 14. So it makes sense that indeed B is 14. We can actually see that, no doubt. B, determine the nth term of the sequence. Determine the what? The nth term. Okay, so I'm going to allow you guys to calculate the nth term, and then you can tell me in the comment section what you get. The nth term of the sequence. The nth term of the sequence. Yes, I'm waiting, don't worry. Okay, I see our friend there. Let's allow everybody else to go ahead and find, so that you can confirm that indeed. Okay, you have two people that have actually indicated that it's 3n plus 2. Okay. Yeah, so Tn is equal to Bn plus C. So obviously our constant difference there we know is actually equal to 3. Then we can choose any term and its position to basically find the value of C. So let's just say we choose position what? Position 1, position 2. Let's say we take that term, the value of which is 8, its position n is 2. Okay, so that means 8 is equal to 6 plus C. We transpose the A, the 6. 8 minus 6 is 2. So C is equal to 2. Therefore, indeed, Tn is equal to 3n plus 2. Very good, guys. You guys are 100% on point. Very, very good. Okay, number C, or letter C. Calculate the value of the 15th term of the sequence. Calculate the what? The value of the 15th term of the sequence. Okay, I will allow you guys to let me know in the comment section. Yes, Alu, we can definitely use that as well. C is equal to T1 minus D. Yeah, can definitely use that to calculate C. Okay, Alu is just letting us know that if we wanted to find the value of C, we could also use T1 minus D. But remember, this one only works if we have the first term, because sometimes you won't have the first term, and the question is, if you don't have the first term, what are you going to do? That's why it's important to know this method, okay? Because once you know this method, that you can substitute any term with its position, then it's easier to find the value of C. But this one requires that we have the first term, and in some cases the first term is not there. So if we have the first term, by all means, T1, that means 5 minus the constant difference, your 5 minus 3, so that means 2. So C is equal to 2. Okay, so once you have that C value, you can just substitute it without doing this, substituting the value of the term with its position. But yeah, this is also definitely a method to calculate the value of C. C is equal to term 1 minus the constant difference. Okay. Yeah. Okay. So we've used B to say the constant difference. So let's just be consistent there. Okay. Okay. Calculate the value of the 15th term. Wanga Ho says 47. Do we agree? 15. T15 is equal to 3 into 15 minus plus 2. So 3 times 15, that's 45, plus 2, which is 47. So indeed, term 15 is 47, no doubt. Which term in the sequence is equal to 83? Which term in the sequence is equal to 83? Which term in the sequence is equal to 83? Which term in the sequence is equal to 83? Right answer is 27. So you're saying the 27th term, in other words, Raylan. Or Khalan, is it Khalan or Raylan? Which term in the sequence is equal to 83? So here we want the position. So we equate 83 with the general term. Okay, very important. Then 3n plus 2 is equal to 83. 3n is equal to 83 minus 2. That is 81. We divide both sides by 3. N is equal to 27. So very true. Which term? It's the 27th term. 27th term is equal to 83, guys. Okay? T27 is equal to 83. Okay, so we now know which term in the sequence is equal to 83. It's the 27th term. Okay? Right. Moving right along. We have a situation here. We have dark tiles D, and we have light tiles are used to what? To create patterns on a floor. The first floor patterns shown below. First four patterns are shown below. Pattern 1, pattern 2, pattern 3, then pattern 4. These are our patterns. 1, 2, 3, 4. We have the first 4 patterns that are shown. We have a dark, 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 dark tiles. Then light, 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 light. Okay. So hopefully we see the pattern, we see it well. So the question is, how many dark tiles were used in pattern 5? That is the question. How many dark tiles were used in pattern 5? Okay, so first and foremost, we should go back and establish what is the pattern for dark tiles. 1, 3, 5, 7. So do you see the pattern that is formed by dark tiles? 1, 3, 5, 7. That's the pattern for the dark tiles. 1 dark brick, 1, 2, 3 dark bricks, 1, 2, 3, 4, 5 dark bricks, 1, 2, 3, 4, 5, 6, 7 dark bricks. So we have a pattern of 1, 3, 5, 7 formed by the dark tiles. So the question that they asked was what? What did they ask? How many dark tiles were used in pattern 5? Do we have pattern 5? No, we have the first 4 patterns. So what is our 5th pattern? What kind of pattern, first and foremost, do we see developed by the numbers that we have here? We have what kind of pattern? It is linear, right? 3 minus 1, 2, 2, 2. We have a linear pattern. So that means 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. That means 7. The 9th, the 5th is 9. Do you see that? So we have that. Okay, and that's how we go about finding the pattern 5. Let's move on. The second question, how many light tiles were used in the pattern number 6? How many light tiles were used in pattern 6? So we want to know how many light tiles were used in pattern 6. So it's very important, first and foremost, to go and count how many white tiles we have. Okay, so in the first, we have 0. In the second, we have 1. In the third, we have what? 1, 2, 3, 4. In the fourth, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is basically what we are seeing when it comes to this pattern. 0, 1, 4, 9, and they are asking us now to actually establish how many tiles there are in the what? In the 6th pattern. Okay. So there's something you should have noticed here. If you are someone who's very vigilant, they are saying in the 6th pattern. Okay, in the 6th pattern. So in the first pattern, we have 0. In the second pattern, we have 1. In the third pattern, we have 2. In the fourth pattern, 1, 4, sorry. In the fourth pattern, we have 9. In the fifth pattern, they want, and in the 6th, they want us to establish how many tiles do we have in the 5th and in the 6th. Actually, not in the 5th and the 6th. They want us to establish how many do we have in the 6th. That's all they want. Okay, so what do we think? Specifically here in the 6th. Okay, so let's first start here. How many would we have in the 5th, first and foremost? And then we can go here to the 6th. Okay, people are saying we have 16 in the 5th. All right, and then in the 6th, you are saying 25. Okay. Okay, I hope we good. I hope we good. I hope we good. Okay, so we would say 25 then, eh? 25. Right. Now let's go here now. Write down the general term dn for the number of dark floor tiles used in each pattern. Write down the general term. Okay. So you'll remember most that our general term there was 1, 3, 5, 7, 9. We want to write down the general term of this pattern. Okay, so first and foremost, we know that it's linear. A pattern that is formed is linear. Okay. So obviously our constant difference is going to be 2. Right? Then we can choose any term. So since we do have the first term, we can actually use the formula T1 minus the constant difference. 1 minus 2, which gives us -1. So that means if we calculate the value of C, we get -1. Okay, we could use obviously the term and a particular position. So let's say we choose term 5, the value of the term, which is 5, which occupies the 3rd position. 5 is equal to 6 plus C. 5 minus 6 is equal to C. Therefore, C is equal to negative 1. So we see, guys, that c is equal to negative 1 can be found either way. Okay, therefore that means Tn is equal to 2n minus 1. So your general term there is 100% correct. It is that. Okay. Okay. If we look at 3.4, write down the general term Ln for the number of light floor tiles used in each pattern. Now guys, this one is slightly different because if we look at this pattern, okay, it is the sort of pattern that is not linear in nature. It's not a linear pattern, this one, okay, because it does not have a constant first difference. So we are going to have to actually apply a little bit of like logic, you know, different from what we actually know. Okay, so slightly different, slightly more different. So here, guys, Tn is going to be n minus 1, the whole thing squared. Now I want to explain why we say n minus 1. The thing is, this is not a linear pattern, so we are not going to use the general term Tn is equal to Pn plus c to find the general term for this sequence. No, not even. What we realize here is that if you take n the position, this is position 1, right? Term 1. So term 1 is going to be 1 minus 1. If you subtract 1 minus 1, you get 0. 0 squared gives you 0, the value of this term. Make sense? That's position 1, term 1. Term 2, 2 minus 1. 2 minus 1 is 1. If you square 1, you get this 1. Okay? Term 3, 3 minus 1. That gives you 2. 2 squared gives you 4. Term 4, 4 minus 1. That gives you 3. 3 squared gives you 9. 5 minus 1. That gives you 4. 4 squared, 16. And so it goes, right? So this is basically the general term of this particular sequence. Okay? We intuitively found the general term not using the formula because this is not a pattern that has a constant first difference. This pattern rather has a constant second difference, and so it's slightly approached differently in the way that we find its general term than what we are accustomed to. So intuitively, as a grade 10 learner, it's something that you just need to know intuitively. Let's go on. Which pattern will have exactly 64 light floor tiles? Which pattern will have exactly 64 light floor tiles? So if you think about it, if we say 9 minus 1, well, 9 minus 1 will give us 8. 8 squared will give us the 64 that we want. See? So as a grade 10 learner, you would basically say Tn is equal to 64. N minus 1 squared is equal to 64. Then of course, guys, you equate Tn with 64. N minus 1, the whole thing is equal to 64. Then we have to solve for who? For n. There's two ways you can solve for n. You could multiply this out. N squared minus 2n plus 1 minus 64 is equal to 0. And then you say n squared minus 2n. 1 minus 64 gives you negative 63, which is equal to 0. then you could solve, okay, using factorization. So n is equal to 9 or n is equal to -7. But we know that n cannot be -7 because a position can't be negative. N is equal to 9. Therefore, we say it's term 9 that is exactly equal to 64. That's for 3 marks. They need to see that working out. Which pattern will have exactly 64 light floor tiles for 3 marks? So we take the Tn, we equate it to 64, we solve for n. And basically, as a grade 10 learner, you should be able to solve an equation that is of this nature, because in term 1, you guys learned how to solve quadratic equations in term 1, didn't you? Yes, you did. You did, guys, you did. So this is not something that should be foreign to you. It can't be foreign affairs minister, this thing. It's something you are used to. Okay, any questions with regards to 3.5, what we've just solved now? Yeah, remember, when you factorize, you ask yourself which factors of 63, when you multiply them, will give you 63. When you add them, give you -2. So I have 9 and 7 because I know my multiplications timetable. I know 9 and 7, when I multiply them, give me 63. When I add these two together, -9 and 7, I get -2. So that works out nicely. Okay, and obviously, -9 plus 7 gives me -2, whereas -9 times +7 gives me -63. So the multiplication of these two factors needs to give me the -63. The product needs to give me -63. The addition needs to give me -2. Right. Now look at this question. Each duct tile is 0.3 meters wide. And 0.6 meters long. Calculate the total area covered by all the duct tiles in the first 100 patterns. Wait a minute. What type of function is 3.5? What do you mean, what type of function is 3.5? This is not a function. This is a pattern. Okay, it's a pattern. I don't understand what you mean by function. This is not a function, it's a pattern. It's a number pattern. And like I said, it's a quadratic pattern, but it's been implied in a grade 10 problem. All right, it's been implied in a grade 10 problem. Yeah. Okay, so once again, each duct tile is 0.3 meters wide and 0.6 meters long. Calculate the total area covered by all the duct tiles in the first 100 patterns. In the first 100 patterns, we need to calculate the area, total area covered by all the duct tiles. In the first what? In the first 100 what? Pattern. So first and foremost, what we need to establish is how many tiles are there in the first 100 patterns. So because if I was to say how many tiles are there in the first, for instance, in the first 4 patterns, how many duct tiles are there? So if I add 1 plus 3, I get 4. plus 5, I get 9, and 9 plus 7 is 16. So I have 16 duck tiles in the first 4 patterns. Does that make sense? Now they want me to calculate, I need to find the area of the first, for the duck tiles in the first 100 patterns. Okay, so firstly, I need to actually calculate the sum, first and foremost, of how many duck tiles I have, okay, in the first 100 patterns. Because once I know how many duck tiles I have in the first 100 patterns, then I can calculate the area of each individual tile. And then after calculating the area of each individual tile, I'll multiply it by the number of tiles I have in the first 100 patterns. And then from there, I'll be able to calculate the total area. Okay, so let's check again. The question says each duck tile is 0.3 meters wide and 0.6 meters long. I think what's easy here is that 2 things I need to find. First, the area of one tile. Because once I know the area of one duck tile, okay, and then after that I calculate how many tiles, how many duck tiles in the first 100 patterns. And what I can do is I will take the area of one duck tile and will multiply it by the number of duck tiles. And then that will give me the total surface area, the total area basically of the tiles of the first 100. Total area of the first 100 patterns. Then I will know. Okay, so this is basically what I need to find out then. Okay, so if I calculate the area first of one duck tile, okay, remember the duck tile is rectangular in shape, so I'm going to say I'm going to use the formula length. Area is equal to length times breadth, which means 0.3 meters times 0.6 meters. Okay, 0.3 meters okay, so what do I get, guys, for the area of one duck tile? What's 0.3 meters times 0.6 meters? What's the area? Not 0.3 times 0.6 gives me okay, 0.18 meters squared. Okay, remember area is measured in square units. Okay, yeah. And then now I need to calculate the sum of the first 100 patterns for the duck tiles. Okay. So if you remember now, if we can just go to that pattern and see what would be the last term, that's 200 minus 1, so we have 199. Okay, so what we are doing here is we are actually adding 1 plus 3 plus 5 plus 7 plus 9, and we are adding all the way up until 99. Okay. we're adding all of these, you know, because we've got one tile that's dark in the first pattern, 3 tiles that are dark in the second pattern, okay, and then in the last pattern we have 99 tiles that are dark. Okay, so what we want to do is we want to add every single value of all dark tiles in the pattern and add those tiles together. Okay, yeah. Now if we were in grade 12, okay, it's nice in grade 12 because what we have is we have a formula that helps us out very nicely when we are in grade 12. But unfortunately, as grade 10 learners, we don't have this formula, okay, and we would have to actually intuitively add each value so that we can get the sum. Now, sum of the first 100 is 100 divided by 2, 1 plus L means the last term there. So that's 100. So what's 100 times 50? That gives us a nice 5,000, right? So that means, guys, we have the number of tiles that are dark as 5,000. We are going to multiply that by the area. And what do we get? 5,000 times 0.18 meters squared. This is going to give us the total surface area of the dark tiles in the first 100 patterns. What's 5,000 times 0.18? We get an answer of what? What meter squared? What's the answer? So what's 5,000 times 0.18, guys? Hey, sleeping, people are sleeping here. Okay, and there we have it. Okay, right, that basically puts us at the end of the live lesson that I wanted to actually cover today, content I want to cover. Okay, so if you missed this live lesson, you are more than welcome to go to my YouTube channel. I'll be uploading this live lesson, let's say by 12 o'clock. Thank you so much, have a good one, and thank you.